Hello everyone, I am Dipansh Arora and I welcome you back to my channel where we were discussing data analysis using Python and we were looking at data visualization. In the previous video, we looked at the Matplotlib library, and in this video, we'll be looking at the Seaborn library, which is also a data visualization library. So here is a brief introduction to Seaborn, which is Seaborn is a Python data visualization library built on top of Matplotlib, designed to offer a more refined and high level interface for creating visually appealing and informative statistical graphs. It simplifies the process of generating complex visualizations, often requiring only a few lines of code. In this lesson, we will focus on the fundamentals of Seaborn, including how to create different types of plots and customize them effectively. So, in my opinion, Seaborn is a better library when it comes to visualization of data, but your opinion might differ from mine. So, let's begin the video. Then, first and the foremost thing, what we have to do is install Seaborn in our system. And just like we installed Matplotlib, we'll install Seaborn by writing exclamation mark followed by pip install Seaborn. And let's run this cell. While it's running, I'll just write a few basic lines of code. That is import Seaborn as SNS. So SNS is an alias, which is the standard alias used for Seaborn. Now you can use any other name here. You can use your name here as well, but it is encouraged that you use SNS only. So for me, the requirement is already satisfied because Seaborn is already installed in my system. Now you can also install this via another route, which is mentioning Seaborn in your requirements.txt and writing here rather than writing pip install Seaborn, you can write pip install -r requirements.txt. So it will instruct pip install to actually read through requirements.txt and install all the requirements. So you can write this command as well, but I have used the Seaborn command here. Okay, so we have imported Seaborn as SNS, and we also have to import matplotlib.pyplot as PLT. So PLT is another alias for matplotlib.pyplot. Now let's run this cell. Okay. Now we'll load some kind of a data set here. So what I'll do is that I'll take SNS dot load underscore dataset, and Seaborn has a lot of data sets inside itself. So you can see those data sets by going on the GitHub page of Seaborn, where you can search on the internet Seaborn datasets, and you'll get a GitHub page where all the CSV files will be mentioned. So one of the datasets amongst the few are tips, which I will be using in this video. So I load this dataset inside this variable tips, and let's print this tips dataset. So as you can see, the tips dataset has the categories total bill, tip, sex, smoker, day, time, and size. This seems to be like a restaurant data where customers who are smokers, customers can come at what time and how many customers came, what tip did they left, and total bill which was actually taken from them, the amount that was taken from them. So this is kind of a restaurant data set. So now let's actually do some data analysis on this data set. So first we'll see a scatter plot. Now to make a scatter plot in Seaborn, you have to write sns dot scatter plot, and you have to pass your variables. So I'll pass x is equal to I'll take two numerical variables. Let's take tip. Actually, let's take total bill here, and as the y variable we'll take tip, and we'll pass the data is equal to tips. Now a good practice would be to write plot.show here, which I have not written. If you are using any other IDE like PyCharm, without writing plot.show, your plot would not appear. So you have to write plot.show when you are using another ID, or if even if you are doing it in VS Code and your extension is not IPYNB, that is, it's not a Jupyter notebook and you are using .py extension, then also you have to write plt.show. So here is a scatter plot between total bill and tips, and you can label this plot as well. So I'll just write a title here, plt.title, plot of total bill versus tips. Okay, I did plot.show has to be uh, plot.show command has to run after plot.title. That's why it showed an error here. Now it won't show an error. Now you have plot of total bill versus tips here. Now we'll look at something else, which is a line plot. Now to make a line plot, I again need two numerical variables, and the command that I have to give, the code that I have to write is sns dot line plot. Again, I have to pass an x variable. So here I will pass size, and on y I will pass the total underscore bill, and the data will be tips. So here you can see a line plot has been plotted. So this is the second coordinate, this is the fourth coordinate, this is kind of the sixth coordinate. This is how your line plot would appear in Seaborn. Okay. Now you can plot some categorical plots as well. So when you have to plot categorical plots, that is, you have to plot the numerical variables based on the categories. So you can do that as well. So let's actually see a categorical plot, which is a bar plot. So for a bar plot, what I'll do is I have to write sns dot bar plot. Sorry for the spelling mistake. X is equal to, I'll write here day, and y will be my total bill, and data will be tips. Let me write plot.show here as well. First, let me give a title, plt.title, uh, total bill based on the days. And now let me write plt.show. So now I'll get a bar plot. So you can see how easily such a huge data set has been plotted, and all the values have been plotted here. Like on Thursday, the bill was this much, on Friday, it was slightly less, on Saturday, it was more than Thursday and Friday, and on Sunday, it peaked. And these lines are the outliers. Okay. Next, we'll see another categorical plot, which is called as a box plot. Now, box plot is very similar to something which you have seen in the stock market charts, which is the candlestick charts. So let me just create a box plot here. I'm not saying it's exactly similar, it's quite similar. So here X will be days, Y will be total bill, and data will be tips. Let me just write plt.title. Actually, rather than writing a title, I'll just simply show the data. Okay, here it's not days, it's day. Okay. Now you can see a box plot. So the baseline actually represents the 0th percentile. The second line actually represents the 25th percentile. The middle line represents the 50th percentile. That is, the data, 50% of the data is below this and 50% of the data is above this. And the top line, this third line actually represents the 75th percentile, and the top line represents the 100th percentile. And all these points above 100th percentile are the outliers. So this is very similar to a candlestick plot, where the base of the candle actually represents the 0th percentile, and the top of the candle represents the median, or the 50th percentile, and the peak, actually the line of the candle, that is the stick on the candle, represents the outliers. So it's very similar to that, but it's a little different. Now after box plot, we'll see something called as a violin plot. Now violin plot gives the distribution of data. To create a violin plot, we have to do sns.violin plot, and again we'll have to pass these values inside. So let me just copy these values from here and paste it inside here. And let's just write plt.show, and a violin plot will be represented. So this is the total distribution of the data. As you can see that the data has peaked here, where the uh, plot is a little thicker, and this is the mean here. It's kind of like a candlestick only inside the violin plot, and this tip actually represents the outliers. So this actually represents the distribution of data, and here it is representing the distribution of total bill with respect to days. Now you can also make histograms using Seaborn. So we'll see histograms. Now to make a histogram, you have to write sns.histplot, and you have to pass something called as something some numerical data. And here I'll pass uh, what shall I pass here? Let's pass total bill only. And I'll write bins. How many bins? 10 bins, let's say. And there is another parameter which is called KDE, which is kernel density estimator. Right now I'll write it as true, and I'll explain it to you what is it. So now you can see the total bill has been plotted, and this is our kernel density estimator. This line which actually smoothens the histogram, this gives the distribution of the histogram, that where the histogram actually peaked and where it lowered. So this curve actually gives the distribution of how the histogram is looking. So you can plot this curve separately as well. If you want to plot this curve separately, you have to write sns.kde plot, and again you have to give tips of total bill as parameter, and another parameter you can give is fill is equal to true. Okay, there is an underscore here. I placed space actually. So now I'll get a KDE plot. Now you can see that it's very similar to this plot. And when we say fill is equal to true, this graph actually fills in with color. And if I just write it false, it will just appear as a line. But it's better to write it as true. It just looks good. Okay. So another amazing plot that you can make in Seaborn is a pair plot. Now, what a pair plot does is, to make a pair plot, first you have to write sns dot pair plot, and then you have to just pass your data set here. Now, what a pair plot does is that it plots all the variables with respect to other variables. That it will give the plots of all variables with respect to each and every variable, even the combinations where like same variable to the same variable combinations will also be there. So let's actually plot this. Now you can see that there are 9 graphs here because there were 3 numerical variables in my dataset. So this has to be remembered that only the numerical variables will be plotted. Numerical variables with respect to numerical variables will be plotted. So I had 3 numerical variables. So the number of combinations was 3 square, which is equal to 9. So I have 9 graphs here. So here you have a total bill versus tip. You have total bill versus total bill. You have again a tip versus total bill, you have size versus total bill, you have size versus size, and you have tip versus size. All the graphs have been plotted here. You have histograms, scatter plot, whatever is the best graph has been plotted here. So this is a pair plot. Now let's look at another thing. Now let's look at something really amazing, which is a heat map. Now to create a heat map, uh, we first have to find the correlation of the data. Now, uh, correlation can only be found between those variables which are numerical. Categorical variables cannot correlate to each other because we have to find the correlation, like how the data changes with respect to another data. So what I'll do is that I'll pass here tips of, and I'll make a list. I have, uh, I think three. I have variables which are total bill. The second variable which I have here is tip, and the third variable which I have here is size. Now I'll find the correlation. Let's actually print this. So this is the correlation of the data. So now you can see that total bill and total bill have one correlation. That is, they will increase uh, systematically. Like the line will be a smooth line, and when the total bill increases by 1, the tip will increase by zero point 0.6 and the size will increase by zero point 0.6 as well, somewhere around zero point 0.6. The same relation we have here, tip and total bill 0.67, and tip versus tip is a 1, and size versus size is also a 1. So where there is 1, it actually represents a smooth graph. That is that they are completely correlated to each other. Now what we'll do is that we'll actually store it in a variable called core, and we'll print this core variable. We get the same data. Now let's plot a heat map. Now to plot a heat map, you have to write sns dot heat map. You have to give your correlation. Then you have to get another variable, another parameter, which is annote, which I'll do as true. And there is another parameter which is the color mapping. So you have to give color map, which is equal to, you can give any color map. You can see the Seaborn documentation for all the color maps available. I will be using cool warm here. I'll do plot.show, and let's see a heat map. Now you can see a heat map, like all the values are in positive. those which are blue, which are near blue, are least correlated. Those which are near red are most correlated. So total bill versus total bill is definitely most correlated, so you see red lines, and you see slightly darker lines here, uh, slightly dark blue lines where the correlation is less, and light blue lines where the correlation is slightly more. And this is how a heat map looks like. So now after heat map, let's do some real world data analysis. So to do some real world data analysis, we have to import our pandas as PD, and then first let me import this. Then we'll do df is equal to pd dot read underscore csv, and I'll use the same dataset which I used in the previous video, which is sales underscore data dot csv. Now let's print df dot head. Just the first 5 values will be given. So you can see that the categories are transaction ID, date, product category, product name, unit sold, unit price, total revenue, region, and payment method. Now in the previous video, I wanted to show you something else as well, which was using Matplotlib. I want to show you that how you can create a plot of a categorical variable versus a numerical variable. Like if I want to plot that what percentage of the payments were paid by credit card, what percentage were paid by PayPal, what percentage were paid by debit card, and like how the total revenue is distributed in terms of payment method, how do we represent that? Now for that we'll need to plot this using a pie chart. So a pie chart is a full circle is 100%, so it will give us the percentages of distribution. So what we'll do is plt.pie, and we'll give our labels first. So what we have to give here is df, yeah, actually we'll give the sizes first. Df of total revenue, then we'll give our labels, which is df of payment method, and after sizes, labels, we have colors also which we can give, and I think that's it. Plot the pie chart. Now let's plot it. Actually I'll have to first find the sum of total revenue. So what I have to do here is that first I have to make df dot uh, find the sum based on product names, sorry, based on payment method, group by payment method, and then I'll be able to plot it. And I want total revenue, total revenue, and I want sum based on total revenue. And what I'll do is that I'll give reset underscore index as well, which will convert it into a data frame, and I'll give it as sales underscore df is equal to df dot group by. So now let's print the sales underscore df. Yeah, so now you can print, now you can make a pie chart out of this. So first we'll give plt.py, and first we'll give our sales underscore df of payment method. Then we'll give sales underscore df of uh, total revenue, and we have passed sizes, we have passed labels, colors we don't care about. What else? Explode, we don't have to explode the data. I think that's it. When we'll plot it, I should see a pie plot. Font deprecated, passing the name. It's the error, could not convert string to float credit card. Okay, so I just passed the data slightly different way. Sizes have to be passed first, and then you have to pass the labels. Can't multiply sequence by a non-int of type float. Why isn't it plotting for me? Sales of total revenue and sales of DF. I don't want to pass colors. I can write auto PCT is equal to mm, percentage 1.1 F percentage. Should actually work now. Okay. So this was the error. I just didn't write labels is equal to sales underscore df, and that's why I was getting an error here. So when you write label is equal to sales underscore df payment method, the error resolves itself, and you get a clear pie chart here where 63.5% of payments were made by credit card, 10.1% of payments were made by debit card, and 26.4% of payments were made by PayPal. So you can see that credit card was the most preferred method of payment. So now we'll actually look at some bar plots using Seaborn. So all you have to do is sns dot bar plot. Now pass your x value, which is going to be df of let's say let's plot this only, this payment method. You have to be very careful with the capital and small letters, because Python is a case sensitive language, and any error in writing would lead to error in the output. And here I will write total revenue. X and Y have been given, and now I have to give data is equal to df. Okay, so variable has to be another parameter that has to be used here is estimator, which is sum. So in Matplotlib, you just saw that I had to actually first do this group by and make another data frame and then actually I was able to plot the pie chart. So here in Seaborn, you don't have to do that much. All you have to do is write another parameter estimator, and you can write your function here, whatever you want to do, sum, mean, count, min, average, and it will work. Again, I'm getting an error here. Let me just correct the error. Length of list vectors must be length of data when both are used, but data has length 240 and the vector y passed the vector passed to y has length 1. Okay, just forgot to write df here. Now you can see that credit card was most preferred, followed by PayPal payment method, followed by debit card. So this is how you make a bar plot in your Seaborn, and this is how you make a pie chart in your Matplotlib. I wanted to show this to you in the last video, but the video was going very long, so I skipped this part, and so I've shown it to you in this video. So this was it with respect to Seaborn. Thank you for watching the video. If you liked the video, press the like button. Subscribe to the channel if you are new. Comment if you have any doubts related to this, and practice a lot. These things require a lot of practice, and you might forget them very easily. So make notes and practice them as much as you can. And again, thank you for watching. I'll see you in the next video.